Hello, welcome to this video on using the quotient rule. I wanted to clarify this because I know it's very easy for students to make a mistake on it. Now, this is what's in your, I've written, put this little arrow on, but in your formula booklet, which you are provided with, it'll say fx over gx, so like you've got a function over a function, a quotient, and then this is your formula. So you are given the quotient rule. As long as you understand it, you should be able to use it. So let's show you how this works. So you've got fx, we're going to call that ln, 2x squared plus 1, and gx is x squared. Now, this, you might need to go back to the chain rule to understand how this works, but a very nice little trick is, I know with ln of a function, that will differentiate to, I've got 2x squared plus 1 on the bottom, and I've got 4x on the top. Well, how did I do that? I know if the bottom differentiates to the top, then it's going to form ln of the bottom. That's worth remembering. That's a very useful rule. Integrating from there to there, or differentiating from there to there. It's a really useful rule. Now g dash x, so I can differentiate that and I get 2x. All done. Now let's just apply this. What does that mean? Well, it means that times that, and we've got to get this right because if you take away, it's not like the product rule where it doesn't matter which way it is around, you must get them in the right order. So I've got 4x times x squared at the top, so this is going to be 4x cubed. It's going to be a bit messy, this one actually, isn't it? 2x squared plus 1 minus this times this, 2x ln 2x squared plus 1. So I've got that times that minus that times that. That's the top. And at the bottom, all I do is I look at the denominator and I square it. So that's x to the power 4. There we go. I'll just make that a bit nicer for you there. So I'm sure we could tidy that up a bit, but I want to concentrate just on applying this rule. Let's have a look at another example. So we've got sine 2x and e to the 4x. So f of x equals sine 2x. I'm using the notation in the formula booklet. Sine of 2x. And then gx, well, that's the denominator. So that's going to be e to the 4x. F dash x equals 2 cos 2x. G dash x is 4e to the 4x. Good reminder of differentiating your trig functions and your exponentials. And then let's just apply the formula. This pair, e to the 4x times 2 cos, I'll put the 2 on the front, it looks nice. Take away this pair, 4e to the 4x sine 2x all over this denominator squared. Well, we square that, it becomes e to the 8x using your laws of exponentials. So that's my dy dx. Sorry, go back there, put dy dx. So that is how you use the quotient rule. It's in your formula booklet. Make sure you're clear on where it is in your formula booklet and you understand it. Because if you forget, that's going to be helpful. Now I could tidy the top of that up, because I could take out a factor of 2e to the 4x. And what do I have? I have cos 2x minus 2 sine 2x all over e to the 8x. Well, that's quite useful because that over that. So I've got, cancel this even further, which might be nice. cos 2x minus 2 sine 2x all over e, oh, can't see that, sorry, e to the 4x. Well, why bother cancelling it through? You might have to find a stationary point, and its stationary point would be when this equals 0. So you're going to form there a nice little equation, and you'll get an equation in tan, which you'll be able to solve without too much difficulty. Well, I hope that is clear. Two nice examples of using the quotient rule. It's in your formula booklet, so good luck with that.